Welcome to the video tutorial on MitoB extraction from mammalian tissue. We're going to be doing it from rat heart tissue today, but the same protocol applies for extraction from cells and flies as well. It's meant to accompany the published protocol we have, so it'll just be a quick practical overview. What you'll want to have to start off is all of your samples frozen on dry ice. You'll want to have the set amounts of MitoB and MitoP for your standard curve. You'll want to have 2 sets of extra tubes for each sample, done up in 2 ml Eppendorfs, and you'll want to have a wash tube done up in 2 ml Eppendorfs, filled with 250 microliters each, one for each sample, filled with 60% acetonitrile, 0.1% formic acid. You'll also want an excess of that buffer. In addition to that, if you're doing this for the first time, you're going to want to have 150 milligram samples, one for each point on the standard curve, that you'll be spiking a set amount of MitoB or MitoP to. We typically use rat liver for our standard curves, but any other tissue would probably suit, would be fine as well. In addition, you'll have wanted to prep a number of 1 milliliter syringes and filters, one for each sample you'll be running for the eventual cleanup of the sample. In addition, you'll also want to prepare a significant amount of the deuterated internal standard, which is detailed in the written protocol, a substantial amount, so that once you've done a standard curve with a certain prepared internal standard, you then do not have to repeat the standard curve until you run out of the internal standard. So the more you prepare, the longer you can go without having to repeat a standard curve. The first step in the extraction process is to blend the samples, the tissue samples, using a hand blender in 500 microliters of 60% acetonitrile and 0.1% formic acid. Typically we run through the samples going in batches of 6 per step. So with the 12 standards and 6 samples I'll be running today, that's 18 samples total. So I'll take in the first 6 first.
Okay,
so
runs.
To each frozen sample, you add 500 microliters of the 60% buffer, and then blend it with a hand blender. Then using a pair of tweezers, just make sure there's no tissue caught in the blender. If there is, just add it back to the tube and blend again. Once the sample is well homogenized, take the blender and one of the wash tubes with 250 microliters of 60% buffer and blend into the wash. And then tip the wash into the original sample and store on ice until you've finished processing all the other samples. So once all the samples are homogenized with a hand blender, we're going to add the deuterated standard mix, 10 microliters of the mix to each sample, and to the standard samples, 10 microliters of each corresponding stock of MitoB and MitoP, which you'll find in the written protocol. So this is the first unknown sample, to which we'll add only the deuterated standard, 10 microliters. So after each sample has been spiked with the internal standard, you just vortex for 30 seconds, each one, before loading it onto a benchtop centrifuge and spinning at maximum speed for 10 minutes. So once the samples have been spun, you'll have a nice tight pellet. You'll want to pipette that supernatant into the correspondingly labeled tube. for every sample you'll want to do that.
Go.
So once you've removed the supernatant from the pellet, you'll wash the pellet again by pipetting 750 microliters of the 60% buffer onto it, and just resuspending it with a pipette tip. You want to resuspend it to the point where you can pipette the sample up and down relatively easily. So once you've done the second spin and combined the supernatants from each sample, you can discard the pellet, and then we're going to run this collected supernatants through a syringe with a filter tip attached to the end. So these filter tips should be prepped by pre-wetting them with a 60% solution, just running some through it with a syringe, and then they can be left following that. So once you have this, you can pipette the sample from the tube into the syringe. And since the filter tips have a tendency to pop off, hold them firmly at the junction here and then push the sample through.